So when we want to sketch a graph, I want you to think about when you very first learn how to graph anything. You would plot points, and that's the way we're going to start off learning to graph these. So the first equation, the first polar equation that we are going to graph is here, and it is theta equals pi over 3. This equation may look familiar because in another video we converted that polar equation to its rectangular form, and I won't have a spoiler yet and tell you what it looked like, but we will review it in just a minute. So when we're told theta is equal to pi over 3, if you'll remember, a polar coordinate is made up of r and theta. Well, since there's no r given here, only theta, we know that theta is pi over 3 all the time. I wrote it down 5 times. You could write it down 3 times or 50 times. We just want to write it down enough times that we can get a general picture. Sometimes we may need to add more pi's over 3 if the picture doesn't begin to materialize as we graph. There's no mention of r, which means r can be anything. So you'll notice I've chosen some r's. What you see here in purple are r values that I just picked. They could be anything. It's good to choose negatives and positives. It's good to choose 0, but I mean, you really could choose any r value. You could choose 1.78315. I mean, all r values are in play here. But these are generating ordered pairs for us. So I'm going to start actually with this one, the ordered pair 2 pi over 3. We remember from plotting polar coordinates, this is our angle. It tells us the angle direction, and then this is our radius, how far we go out from the pole. Well, here's our pole. Here's pi over 3, so I will step out 2 steps. 1, 2, and put a dot. Okay? Well, my next ordered pair is 1 pi over 3. You might wonder, Ms. Hall, why do you have them out of order? The ordered pair has to be r theta, but typically our equation will have us, we would need to know theta in order to figure out r. So that's why I have it listed as I do. Our angle is still pi over 3. This time we're stepping out 1. Then we have the ordered pair 0 pi over 3. I have some lovely Easter colors going today. So I'm going towards pi over 3, but not really, because if my r is 0, I'm just sitting here on the pole. So when we are talking about rectangular coordinates, that would be the origin. When we are talking about polar coordinates, that location is called the pole. Moving on, we have the ordered pair -1 pi over 3. If you'll remember, with our negative r values, instead of going toward the angle, we go the opposite direction. It can be kind of hard to find all those little lines in there. They're kind of jumbled up. Well, the opposite direction simply means that we would add pi to our angle. So pi over 3 plus pi would be 4 pi over 3. So instead of going towards pi over 3, the negative means I'm going in the opposite direction, which is towards 4 pi over 3, 1 step. Pi over 3 being the slope, which is square root of 3. Well, if you will remember, when we converted this into its rectangular form, it was y equals square root of 3 times x. So not surprisingly, when you put it all together, this graph turns out being a line. Well, you might say, Ms. Hall, I thought we were going to do some fun and interesting graphs. And lines we've done a million times. Correct. So we will turn our attention to this. Now, I have already begun the process of this, and I want to tell you what's been done, and then we'll pick it up at the graphing part. So we have, this is our task. We are asked to graph 2 minus 2 times the cosine of theta, r equals 2 minus 2 times the cosine of theta. Well, what you see here is a list of ordered pairs, or a list of theta values. Notice that I have from 0 to 2 pi. I'm going with our typical unit circle values, but you could use any theta values that you want to, but these are good ones to use. Sometimes if the picture doesn't materialize, you'd have to go back and maybe use these ones that are over 12 that you see listed on my polar coordinate graph paper. So what we will do in each case, and I've got the process shown down here, we'll take our theta. So the first one is 0. Sorry, I left it out in the original list. So we plug 0 in for theta, and we evaluate 2 minus 2 times the cosine of 0. Well, the cosine of 0 is 1. 2 times 1 is 2, and 2 minus 2 is 0. So that leads me to the ordered pair 0, 0, which we see here. Then we plug in pi over 6. Cosine of pi over 6 is square root of 3 over 2. 2 times square root of 3 over 2 is just square root of 3, so the exact value is 2 minus the square root of 3. Well, if we're going to graph this, a decimal approximation would probably be more helpful, so I went ahead and calculated that and got 0.3. All right, so now for the fun part. Let's sketch the graph of this. We are going to sketch these points and then connect them in order, so like it's a great big connect the dot. So we've got the ordered pair 0, 0. So I'd go to the angle 0 and go out to 0. That's really just the pole, what we would have called the origin in our rectangular coordinates. Then we have the ordered pair 0.3 pi over 6. So I'll go towards pi over 6, 0.3. So that's just a teeny tiny bit out. Okay. Then I have 0.6 pi over 4. So towards pi over 4, I will go out 0.6. I have the ordered pair 1 pi over 3. Towards pi over 3, I will go out 1 step. 2 pi over 2. Towards pi over 2, I will go out 2 steps from the pole. 3, 2 pi over 3. 1, 2, 3. 3.4, 3 pi over 4. There's 3 pi over 4. I'll step out 1, 2, 3.4. 5 pi over 6, 3.7. Officially 3.7, 5 pi over 6, but I'm going to go towards 5 pi over 6. 1, 2, 3.7. Towards pi, I'll go out 4 steps. 1, 2, 3, 4. 3.7, 7 pi over 6. 3.4, 5 pi over 4. 3, 4 pi over 3. 2, 3 pi over 2. 1, 5 pi over 3, 0.6, 7 pi over 4, 0.3, 11 pi over 6, and then 0, 0. Now it's connect the dot time. So starting at our original ordered pair, which was 0, 0, and connecting the dots, we have a little shape here. And many of the polar equation graphs have special names. This particular graph is called a cardioid. And I wonder if you could imagine why that is. Looks a little heart-ish. Maybe even more of an anatomically correct heart, but nonetheless, this is called a cardioid. So when you are graphing polar graphs, you are going to make a table, plot your points, and connect the dots.